Recording started.
I almost forgot to do one of the most important things, which is to record it. So you can see I'm a newbie. Okay, well, we're going to start off today answering a couple quick specific questions that came in. But then I want to kind of delve into the world of average, which I realize for a lot of people is probably a pretty straightforward, easy concept, which is why really what I'm focused on today will be trying to see if we can get through some of these problems in like a minute. I think these are problems where we can a lot of times take a pretty good shortcut and bank some time. So real quick, let me just respond to a couple quick specific questions we had come in that were on the verbal side. One of them is this sort of idiomatic choice between using because of versus due to. I got to be honest, the first time I saw this, I was like, are you serious, GMAT? Like I'm supposed to care which is which. Does anyone out there have any theories on when one is appropriate versus when the other is? They both can be used appropriately, but there's sort of a preferred usage of each one. All right, interesting. I didn't either, so you are in good company if we assume that I'm good company. Take a look at this. I'll let you guys know one of these is considered right, one of these is considered wrong, and maybe I will just have you vote. I'll put polling options in a second, and you can tell me whether you want to vote for A or B. All right, well, get your vote in if you have a choice. Some of you are like, this is arbitrary. But Namie nailed it. I am so proud and or impressed. Due to is to be treated as an adjective, whereas because of is to be treated as an adverb. So what do adjectives modify? You can just type that in the chat window. What do adjectives modify? And what do adverbs modify? Verbs and one other thing too. You know what else adverbs can modify? Other adverbs and other adjectives. Yeah, I should have written adjective or adverb as well. So in this example, this modifying phrase, due to the loud noise, because of the loud noise, it seems as though we are we saying that he is due to the loud noise? Or are we saying, he screamed, that the screaming was was from the loud noise? So because we are really describing where the scream came from, we want this adverbial connection. And so the second one is correct. Let's give a little bit of applause to Namie. Hopefully I'm not butchering your name, Namie, but that was impressive. I don't know how you did that. Okay. Let me give you just a couple more examples. If this would be due to being used properly. Sorry that I picked grim examples. She had a terrible scar due to her motorcycle crash. This is okay because what is this modifying phrase really modifying? What is it describing? Awesome. Yeah, the scar. So since we're really saying the scar is due to her motorcycle crash, we're cool with using due to here. Whereas, I'm going to get this out of the way. If I say, she was very cautious because of her motorcycle crash, now what is this modifying phrase describing? Any idea here? What do you think we're saying here is because of her motorcycle crash? Yeah, her cautiousness. If we actually said her cautiousness and we made it a noun, we could say, oh, her cautiousness is due to her motorcycle crash. But here we're using it as an adjective. We're saying she was very cautious. So we can either, because the adverb has this flexibility, we could either say it describes why she is cautious, why she was cautious, in which case we're modifying a verb, or we can just say it describes why she's cautious, in which case we're modifying the adjective. In either case, we're not modifying the noun. We are not saying she is because of her motorcycle crash. So, give me a smiley face if you feel like you get that very obscure but idiomatic difference between because of and due to. Okay, I've only seen a couple smileys, and feel free, let me know if you have any questions about this before we move on. I don't expect you to see this a ton, but at least now we know the justification. And we can feel smarter around other people when they get it wrong. And isn't that what this is all about? Dinesh, you're just asking what's going on, you just joined. We were talking about the difference between because of and due to. You can go back and watch the recording later if you missed something. It is Thursdays with Ron. I'm guest hosting today because Ron is out. He had knee surgery this week. So I'm answering a couple quick questions that we had, and then we're going to talk about the broader topic. So the other quick grammar question we had was, you know, sometimes you see those funky sentences where they start the sentence with like the word that or who or why or which, and it makes for a really kind of awkward sentence. What's really happening there is you're just reversing the order of subject and predicate. So, you know, the sunsets are beautiful is obviously a fine sentence, but it's also okay to say beautiful are sunsets. It doesn't sound as natural, but it's okay to reverse the order of that. So if we get a little more complex, like the gold standard is no less arbitrary than paper money. I can flip that around and say no less arbitrary than paper money is the gold standard. So again, if you see this in an answer choice, it's kind of designed to not be appealing, but there's nothing technically wrong with it. If you can just picture in your head, I mean, use the verb sort of as the dividing line, and just think, you know, would this sentence be okay if I just rearrange that? And so the gold standard is no less arbitrary than paper money. And if you're saying yes, then it is acceptable. There's nothing wrong with doing this. A couple more examples. We couldn't believe that she was only 30 years old. I could flip that around and say, that she was only 30 years old, we couldn't believe. I don't know why I have to change my accent when I say it backwards, but it's such a pretentious way of saying a sentence. It is a mystery who poisoned the applesauce versus who poisoned the applesauce is a mystery. Okay, so that's it. There's, I think that hopefully, I don't know if that person who asked the question is here, but I mean, essentially I think people are put off by this format, but all you're really doing is arbitrarily choosing to switch the order of the subject and the predicate. And in a sense, you're treating something like this as one big noun. You know, if a phrase like this looks like it's about to start a question, but you're really just saying this is a mystery. What is this? Who poisoned the applesauce? Okay, let me know if you have any questions with any of this before we move on. See a couple people typing stuff. Dinesh saying, is a mystery? Correct, since who modifies the mystery? Dinesh, you want to hop on the mic? I'm not sure if I understand the question as you wrote it. Hello? Hello? We could hear you, Dinesh. Go ahead and ask your question. What were you asking about? Okay. Well, I don't know what happened there. I think you were just asking if the original was correct. All 8 examples on here are correct sentences. I was just pointing out how a very normal sentence can be made to sound less normal by flipping around the order of what you're talking about. Okay. Well, barring any questions, I see someone typing something, but I'm going to tentatively move on unless anyone wants to stop me. Okay. So, as I said before, but some of you guys missed this, what I want to talk today about is averages, and in a sense we'll touch on median a little bit and weighted averages, and even as this idea sort of manifests itself within rate and work problems. Yeah, if you hear the audio speed up, it generally means that your connection was lagging for a second, and so as the as the program tries to catch up to real time, it'll accelerate my voice. Okay, I hopped off the mic for a sec. You can, if you let me know when that's happening. If I hop off the mic, sometimes that allows the computer to catch up a little more easily. So anyway, I was saying to thanks. I was saying to people at the outset that I think actually most people are pretty successful at these questions, but what I really want to push us to do today is to get them in like a minute. So I hope you're ready for a lot of problems because I want to basically see if we can get these done with only a minute on the clock. So with that in mind, go ahead and give this one a try. Pull in your answer when you're done. Okay, go ahead and take a guess if you would. I am definitely hijacking half of your time, but that is sort of the theme of the day. So this looks ugly when I first look at it. I am not a fan of sequences and subscripts, and I think that's designed to throw a lot of people off. Let me see who's got a mic. Miriam, I think you said you're not sure if your mic works, but can you give it a try and let us know? How did you rephrase this question, or just walk us through your thought process of going through the problem? It looks like she's typing that she has no mic. Prabhakar, I don't know if your mic is working, but if you want to. Okay, so Miriam's saying the first thing you saw was they weren't consecutive. Did something tell you they were not, or you're just saying because it never said they were consecutive, you were thinking, well, I don't have to assume these are consecutive? Okay, because they never said so. How would that change things? If they said if the terms of a sequence, I'm going to squeeze it in, of consecutive integers, oh, well, sorry about that. Does this change anything if they said if the terms of a sequence, sorry, I plugged in the wrong spot. If the terms of a sequence of consecutive integers are blah, 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 what's the value of n? Does that actually change anything? I mean, would it change anything in terms of statement 1 or statement 2 being sufficient on their own? What do we think of statement 1? Like, if we knew that these were all, I mean, asking us for n is basically saying how many things are in the sequence, right? Because, you know, if there were 3 items in the sequence, we would stop at the 3rd term. Since there are n terms in the sequence, you know, n is just a number of terms. So you're saying B would be sufficient. How come? If we knew that the average was 4, what does that tell us? We have our first debate of the day. What's the special property that we really care about when we deal with consecutive integers? Besides me trying to spell it. Does anyone know like the most important property? The average is the middle number, the middle value is the mean. Dynamite, yes. So this is the only time where we are guaranteed that the mean and the median are the same thing. It can happen in other cases randomly, but with consecutive integers and evenly spaced sets, you know it to be true. So I agreed then that B would be sufficient if this were consecutive integers. If you knew the middle term was 4, then you basically know you have to just keep going a certain number of terms to the right and to the left until the entire set adds up to 3124. I don't know that that actually is possible, right? Because ultimately, I guess it is. You do have a notch up here. I guess it is possible. Yeah. Key, what do you mean? It does not even say whether it's positive or negative? I don't know what the VE stands for. Oh, you're just saying an abbreviation for positive or negative. Yeah, exactly. Like, if this is the middle number, it will have to extend a long way up positively and negatively to ultimately, actually, sorry, statement B would not be sufficient by itself. I got tangled up there. I mean, how would this help us? Like, if the average of the n terms is 4, then, you know, we just know that 4 is the middle number. We do know that n is odd, Dinesh pointed out. If the mean and median of a set of consecutive integers is an integer, then you know there's an odd number of things. Does anyone know what would be, like, what do we know? I'm going to write it out so you know. What do we know about the mean of an even numbered set of consecutive integers? Awesome, it's not an integer. How come? What is it specifically? We can kind of assign a value to it. I mean, we know part of that number. Yeah, you'll be splitting. Awesome. So Maria and Miriam both have it. You know, you'll be averaging together 2 consecutive integers, so it will be halfway in between. It will be a 0.5 guaranteed. Okay. So anyway, getting back to this, statement 2 would not tell us how many things are in the set because, you know, we could have just this. We could have, I mean, technically from here it looks like we have at least 3 things, but we could have 5 things in the set. We could have 7 things. So if we added consecutive integers, it still wouldn't make B sufficient on its own. Would it make A sufficient on it, statement 1 sufficient on its own? Is there only one set of consecutive integers that adds up to 3124? Awesome. Yeah, Key is correct. I mean, there's a lot of different ones. I don't know exactly what the numbers would be, but I'm just going to be estimating here. Like, it could be a set of like 3 numbers, assuming that's not actually a multiple of 3. But you get my gist. Like, it could be a small set of big numbers. It could be a really big set of small numbers. So in and of itself, that's not going to do it. What about together? Would it be sufficient together? Nice. Well, those aren't consecutive integers, Jay. We were talking about if we added to this problem the consecutive integer thing, just because we were kind of curious what sort of complexity. Yeah, it would be sufficient, although, that's all good. Don't worry about it, Jay. Do we even need it without it? Some people pick C anyway. Let me see if I can find anyone with a mic. Maria, if you have your mic, can you hop on and tell us why do you think that this is sufficient anyway?
Hey, hear me? Okay, so I picked C because for statement number 1, I wrote the equation 3,124 over n equals the average. And then statement 2, I said it was also not sufficient because 4 equals x over n. And we don't know what x is. But if you combine statements 1 and 2, you get 3,124 over n equals 4, and therefore you can solve for n by cross multiplying.
Okay. Sorry. Yeah, awesome work. Ultimately, this whole question, I mean, just hinges around the typical formula for finding average, that we have the sum, we divide by the number of things, and we get the average. The thing is, you know, we think of average so much in real life as performing this calculation, but when you see it on tests such as GMAT, they almost never give you the sum and the number of things and ask you to calculate the average, because that's too straightforward for people. They'd much rather give you like the average and the number of things and have you calculate the sum, or in this case, the sum and the average, and have you calculate the number of things. But as soon as you see any parts of this equation, then write it down, and just as she was saying, you'll kind of see on the page, oh wait, I've got all the pieces I need. I think the hardest part of this problem is just decoding that n just stands for the number of terms, the number of things that are being averaged. Once we get that, we're like, oh, yeah, these are just the two pieces of the average formula, two of the three pieces. Okay, so C is the correct answer. Does anyone have any questions on this one before we move on? No, I don't know if it's Jean or Jean, or hopefully I'm not mispronouncing your name. We were, that was just a student brought that up. She was saying that she initially noticed that it didn't say consecutive integers, and we were kind of just playing around with that hypothetical of what if it had. We don't actually, it doesn't matter, we don't have to assume these are consecutive integers. It doesn't have any relevance to us working through either of those statements. Oh, second form, now I forget which one it was. Jean? Is that right? Let's go with Jean. Yes, nice. Okay. I was like, second form, what are you talking about? Correct. Yeah, I mean, consecutive, it would still be C, because as we looked at in both individual statements, we wouldn't be able to get any sufficiency out of there. So it's C either way. Okay, so let's ramp it up a little. Give this one a try. Again, I'm going to be aggressive and only give you a minute. All right, I'll give you guys a little more time on this. This is harder than I gave it credit for. Give me another 30 seconds. All right. Let's talk through this. This is a little tricky. What do you guys think is the first thing I want to do with these numbers when they're telling me that x is the median of those 5 numbers? Sort the list, John says. Agree. So I mean, median, we can only really analyze that by having them in order. What else is relevant here? I mean, there's an odd number of things in this list. So how is that going to affect how we figure out the median ultimately? Awesome, yeah. So when it's an odd number of things, the median is an actual value. It is one of the numbers. So are there any numbers that it simply couldn't be? Are there any numbers that could not be the median? I'm saying before we've looked at statements, Dinesh, I don't know if you were saying 7 from what we learned from the statements. I mean by itself. So 1, 3, and 12. Some people are just saying 1 and 12. Yeah, 1 and 12 are too far away from the middle. Like, I could potentially put x here, in which case 3 is our median. I could put it here, in which case 8 is our median. Or I could put it in the middle, in which case x is our median. So we do know for sure that our median is either 3, 8, or x. What about our average? Is there anything, since they want me to compare the median to the average, is there anything I can do with this before I look at statements to think about what I know about the average so far? Okay, cool. So people are saying, to do the average, we're going to ultimately add this up and divide by 5. And Maria is taking us right to the punchline of that, saying right now we've got a sum of 24, and we're going to be adding whatever x is and dividing by 5. So you'd think maybe that is it true to say that the smallest my average could possibly be is like 5, because the smallest I could ever make x would be 1? Are there any limitations on the average? Next. I hope that means that we could still do negative x, or maybe you just meant negatory on that question. Either way, I don't know what your code was. There are no limitations. I like it. Okay. So since x can be any integer, we don't really know much about the average. So if we consider statement 1, Dinesh, you want to try your mic one more time? You thought statement 1 was sufficient. Can you tell us how you think it would be sufficient? And Dinesh, I don't think you are hitting your mic button. Mohit, what about you? Does your mic work? You were thinking statement 1 is not sufficient. Can you tell us why not? All right, I'm going to stop calling on people, I suppose. If you want to tell me, go ahead and raise your hand. Let's otherwise just use the chat window so you guys seem comfortable with that. If we know that x is greater than 6, do we know what our median is yet? Can we rule out any of these possibilities? Could the median still be 3, 8, or x? Yeah, it can't be 3 anymore, but people are correctly thinking could still be 8, could still be x. And then, do we know anything about our average? Not really. I mean, we know it's at least 30 total. So if you thought this was sufficient or insufficient, give me a reason why. Go ahead and type it in the chat box or hop on the mic if you are so bold. All right, so we're saying it will not be 31 because x is greater than 6 and not greater than or equal to. So because it's greater than 6, saying we know for sure that our average is going to be greater than 30 divided by 5, i.e. greater than 6. So great, we know our average is greater than 6, and we know that our median is either 8 or x. From those two facts, can I tell whether or not the average is greater or not than the median? The 30 came from, so we had the average equation already set up, right? We know that ultimately to find average we're going to be adding all 5 things and dividing by 5. Currently, from the 4 numbers we got a sum of 24. So if this statement is telling me x is greater than 6, if I think to myself about the average, so I'm doing 24 plus greater than 6 over 5, I'm going to get something bigger than 30 over 5. I'm going to get something bigger than 6. Let me know if that makes sense. But it still seems very possible to get either answer. You know, one quick way, I mean, a lot of times when you're trying to say that something's insufficient, it's sort of hard to convince yourself unless you just provide some numbers. So, I mean, we could think to ourselves, all right, well, so what if I just make x pretty small? 1, 3, 7, 8, and 12. In that case, the average, the median would be 7, and the average would be, let's see, 31 divided by 5. And so, you know, that's like 6.2. So that's an example of a yes or a no answer. Would I label this on my page as yes or no? Sweet. And the reason that I'm forcing you guys to tell me that is because this is really an important habit of yes-no data sufficiency. If you're trying to prove to yourself something is insufficient, then you have to carry it through all the way to the answer choice and just, you know, use a set of numbers and then go, all right, I know I can get a yes answer. Can I also get a no answer, which means can I get an answer where the average is bigger? So can someone give me a version? I think we saw that before. I mean, I saw you guys offering ideas like that. But can you give me a version where the average would end up bigger? What could we make x so that the average would be bigger? Cool, like 100, like 1,000,000, like 100,000. So if we say that 8 is going to be our median, then we can make x basically I'll go with the real number called a bazillion. And if x is a bazillion, then the average is going to be bigger than 8. So this is insufficient. We should have our A, B, B, C, E grid down and get rid of it. Alright, let me get rid of some of this. And let's look at statement 2. Oh boy. That's not coming back easily. I apologize. There's no real quick way for me to get that screen captured back. So we canceled 3 for the median because x was greater than 6. That is going to be tricky. You do have a copy of it? Okay. If you can remind me what it says, it might be hard for me to find. So we had 1, 3, 8, and 12 and x originally. And the reason we thought that x could be the median is because we were thinking to ourselves, well, what if x was the first value in the set, or even in between 1 and 3? If x is less than 3, that makes 3 the middle number. But statement 1 told us that x was greater than 6. So there's no way for 3 to be the middle number. We know that x will end up somewhere to the right of 3. So that meant only 8 or x now could be the median. Either 8 will squeeze in the middle and be the median, or, either x will squeeze in the middle and be the median, or x will be somewhere to the right of 8, and 8 will be the median. So we just meant that for this statement. So does anyone remember what statement 2 said? That's really what we're missing. Go for it, John.
Statement 2 says x is greater than the median of the 5 numbers.
Terrific. So does that eliminate anything in terms of our possible medians, 3, 8, or x? Yeah, obviously x can't be the median anymore if it's greater than the median. Could it still be 3? Could it still be 8? Knowing that we have to put x somewhere bigger than the middle number. Yeah, we still, 3, 8, or x has to be the median. We can't say that those are all gone. There's no way that 3 could be the median, again, just because, just like statement 1, the only way that 3 was going to be the median is if x was less than 3, because that's the only way to get 3 as the middle number. If we know that x is greater than the median, we know it's greater than 3, and now we know it's greater than 8. So really what statement 2 seems to be telling us in code language is that the median is 8 and that x is greater than that. So if we go back to our whole question of how we were thinking of the average, is this one sufficient? 24 plus something greater than 8. So what's the smallest version of that I could try? Yeah, 9. Since we were working with an integer, it did say that x had to be an integer. The smallest thing I could come up with would be 33 over 5. 33 over 5 is 6.6, I believe. So right now we have the median greater than the average. Sorry to get rid of this other stuff, I just need some room. So it is still possible to get a yes answer where the mean is where the median's greater. Is it still possible to get a no answer where the mean would be greater than the median? And Dinesh, what kind of value for x could work? What could we make x a bazillion? Thank you, Marion. I was hoping to get a call back to that. So, yeah, because we have the freedom to play around with x and now make it as big as we want to, we could definitely still make the mean grow higher than 8. So ultimately, it seems like this would be E, would it not? I mean, together, do we get anything? Statement 1 told us that x was greater than 6. Do we gain any information from that when we look at, like, knowing statement 2, does statement 1 tell us anything additional or helpful? No, and this is when you get to that moment when you're testing C and then you're like, oh God, there's absolutely no cooperative value here because I already, this statement's already telling me it's greater than 8, so that tells me nothing. Then that actually makes your work pretty quick with C. You're like, all right, well, it can't ever be C unless considering them together added something to your knowledge. If one of the statements is contained in the other one, then it can't be C. So this was actually, how did we know that the median was 8? Well, you mean based on statement 2. We knew that we always had these 5 quantities, 1, 3, 8, 12, and x. So we said, if x is less than 3, then the median will be 3. The middle number, we'll say, I'll just make it like this, even though it could be a bunch of different ways. If x is greater than 3 but less than 8, then you get 1, 3, x, 8, 12. And then, make some space. If x is greater than 8, then we've got to have 1, 3, 8, x, 12. Hard to say. I guess I would probably put it up in the upper 600s. I mean, I don't think it's killer math, but it's hard to untangle possibilities when you're dealing with this, because you definitely have some flexibility, and you sort of have to, the fact that you have 3 potential medians to choose from is definitely sort of a minefield of different possibilities. And I don't think the statements are too obvious about what they're telling you. And I don't think a lot of students will follow through with actually coming up, convincing themselves that that there is an example that goes both ways. Where are we getting the if statements from? The idea of median is that if you arrange the 5 numbers from least to greatest, yeah, I definitely shorted you. It looked easy. That's why I only gave you a minute, but that was much harder than I thought it was going to be. Miriam, when you're trying to find the median of 5 values, it's going to be the middle value, but because we don't know where x falls in this list, we don't know right now which one will be the middle value. So we realized that there was no way that 1 or 12 could be the middle value because they're just too far away. But if I put x, in the front of the list, then that means that 3 is the middle value. If I put x at the end of the list, that means that 8 is the middle value. And if I put x in the middle of the list, then that would mean that x is the middle value. So if things were a little bit arbitrary, I mean, these statements are true where I assigned x here and here is a little arbitrary. But the idea is, there's 3 different possibilities for which of these 5 quantities could fall in the middle. It could be the 3, it could be the 8, it could be x. That's why we initially, before we even looked at statements, we did that work ahead of time. And then we also did the work of, all right, the average equation is going to be 24 plus something over 5. Okay, let me know if you guys have any questions about this before we move on. All right, this one I think will be easier. Let's give it a try. All right. Let me start you off with a kind of simple question. What do you think is the trap answer here? If they tell me that the average is 7, median is 9, what's the lightest one going to be? Does anyone know what kind of trap answer here is sort of too good to be true? Okay, nice. So 1 is a trap answer because it's just the smallest number on the list. And that's kind of appealing to Joe Simpleton, who's like, I don't know both. They want the latest. Well, actually, wouldn't it be the biggest number? We should probably actually say E is the trap answer here, because they want the maximum number. Is there, why were you guys saying 1 was a trap answer? It is the lightest, but they are asking for the maximum of the lightest. But I guess I'll throw that in there. They both could be, since we're talking about Joe Simpleton here. Okay, so if you're dealing with a set, I think problems that ask you to analyze stuff in relation to the median, for me it helps a lot to actually just physically draw the 3 spots and the median. So I know that, with 3 things, because there's an odd number of things, that the median just is the middle number. So I got a value over here, I got a value over here. What does the fact that the average is 7 tell me? Is there anything that I can learn from that? Total equals 21, awesome. And again, they don't give us the sum and the number of things and ask us to calculate the average. They give us the average is 7 and the number of things is 3, and from that we're supposed to get that the sum is 21. So first plus last equals 12, so I'm going to say nice. Okay, so if we think of this as the first and the last, we know that there are 12 things left to go around. And so if we want, these are from gmatprep, from the free software you get from mba.com. If we want to make this as big as possible, what should our strategy really be? Dinesh is given us the value, but how do we, what's the guideline there? Why am I trying to make this last one 9? Awesome, yeah. So we refer to these as optimization problems. The idea that if you're trying to max out this, then you have to minimize everything else, because basically this is your budget. And so remember that within a set, you can repeat numbers. I can't go any smaller than the median once I go to the right, but it could be the same. Awesome, minimize the heaviest box. And so knowing that, we could set up this equation. We could also think to ourselves, sorry, hold on one sec. I pressed the wrong button, which makes my computer freeze for a second. Okay, we're back. You can also think to yourself, we're going to get to this chart again in just a second, that if 7 is my average, and I know I've got 2 9s over here, they're each pulling me 2 to the right of the average. So to balance that out, I need a number that's going to be 4 under the average. I need a 3. Now, give me a smiley face if any of you guys have ever seen this chart before, the sort of over and under chart that deals with average. Okay, that's ultimately one of the things I want to get us used to today, because it, yeah, we'll use it in much cooler capacities than this. This one, we can easily just set up this equation. But the idea with an average is basically, it's like a tug of war. An average is the fulcrum, the balance beam between all the numbers that are above it and all the numbers that are below it. So if I know that the average is 7, and I know that there are 2 9s here, I know that because I want to make this as small as possible. Each of these 9s is pulling 2 points of strength above the average. So to balance that out and make 7 perfectly balanced in the middle, I need to be 4 under the average on this side. Since I'm only out here allowed to have 1 number. It's because if I'm like, all right, I need 1 quantity that will allow me to be 4 under this. You should do this one in your head. The answer is C real quick. I do want to move on because this is a pretty easy one. Let me skip ahead for a second to just a silly problem that I wrote. Take a second to think about how you would set this up. Okay, so can someone type it in or hop on the mic? How would you set up this problem to solve for x? Okay, so key has, I think, the idea that most people would say, Rigel, I don't know if I'm hopefully not mispronouncing your name. I'm not sure. Maybe you can explain what the +7 will mean in a sec. I think you might be thinking along the lines of what I'm thinking. But so Key's method, I want to make sure everyone's cool with that. You know, we know these four things have an average of 370, so we can definitely say this plus this plus this plus this divided by 4 equals 370. Awesome. So there we go with Mohic's. So the easier way to do it without having to add up those ugly numbers is to just think of it as a numerical tug of war. You know, 370 is the average. He's in the middle. I've got 384 above the average. I've got 357 and 362 below the average. So I'll look at what we got so far. You know, this is pulling me 14 above. This is pulling me 13 below. 262 is pulling me 8 below. And so we've got a total of -21 on this side. Yeah, so if there's a total difference in the average of -21 on this side, then I'm going to need +21 on this side to balance it out. So what they were saying is, all right, well, if I already have +14, what I need here is another +7. That'll balance it out and make this a never-ending tug of war. And so if I'm saying what is this missing number that is going to pull it 7 above 370, you know, I just count up 7 from 370. And so we never had to deal with the ugly math of 370 times 4 and then subtracting all this garbage. Let me know if you guys have questions about that. So we will see yet another way to use this chart for weighted averages later, but the whole idea of the concept of average as sort of the middle number on the number line, or sort of the thing that cancels out all the weight being pulled to the left and all the weight being pulled to the right, is an important one. Let me ask you a quick follow-up question. Say that I said the average of a certain set of numbers is X. If I told you that the smallest number in the set is X, does that tell you anything? Yeah, Maria, we'll get back to it. Let me go ahead and finish this question while we're on it. Jay, can you explain why? I don't know if you have a mic on you or not, but otherwise, can you type it in or hop on the mic? All right, I don't see you jumping on the mic or typing. So you guys are right. Yeah, it means all the numbers are the same. If I have X as the smallest number in a set, but I want the average to come out to be X, if I put any bigger number in there, then the average would have to be the in between X and that number. Awesome. Miriam just said it perfectly. If there were any bigger numbers, they'd pull the average to the right, and it would be bigger than X. So if I need the X to be the balancing number that balances everything above and below it, and you're telling me there's nothing below it, and there's not allowed to be anything above it either, because that would pull it off balance. So Maria was asking to go back to this chart since this is a new thing. So the okay, cool. The idea is the average goes on top here. Then you write the numbers that are pulling it in either direction. Right. Awesome. Dinesh is saying the average will always be within the two extreme values. Okay. So let's go back to a fresh problem. Try this one. I'll give you a little more time to ponder because pretty much no one has an answer yet. All right. This one also gets pretty tricky. It's definitely testing again our concept of the flexibility of what we actually learn from median. When we have 15 ingredients in a set, like what's our flexibility of playing around with things? So if we have 15 homes and we know the median is 130,000, does that mean we actually sold a house for 130,000, or is that just a figure we get a different way? Yeah, because there's an odd number. You know, we know the median is really an actual value in that set. So we know in the middle of this set there is a $130,000 value. And we basically know that there are 7 more values to the top and 7 more values to the bottom. That's how we're getting our 15. What do we know from the fact that the average is 150,000? Awesome, yeah, we can figure out the sum. So again, 15 times 15, he made use of the knowing 15 squared is 225. So we know the sum is that big old multiple of 225. And we also know, as he is saying, that it's heavier on the right side. Because if this were, if it were equally balanced, then this middle number would be $150,000. We're going to need some bigger stuff up here to make the average come out to be 150,000. So let's look at them one at a time. Do you think that case 1 has to be true? Does there have to be at least one home that's more than 165,000? Rigel, I didn't see when you typed that. I don't know, were you saying that in response to the first case? Since they're asking what must be true, it doesn't actually really interest me to see whether or not this is possible. I want to see whether or not I can avoid it. So can you think of a counterexample here where we wouldn't have any homes for more than 165,000? I'm not sure I know what plug B for 165,000 means. But something Dinesh said before, that the average has to be between the two extremes, could matter. I mean, we could ask ourselves, the max value is less than 165,000? Well, why do we know that? Let's dumb these numbers down and stop thinking in terms of thousands, and actually, you're saying sufficient as in, like, it has to be true. This isn't really data sufficiency, but I assume by sufficient you mean it must be true. If you think about this just as a 13, that could kind of help. If we were trying to make this smaller than, to keep all of these smaller than 165, okay, so yeah, Mohan, why are you saying that? Why is there no way to get that high an average without at least 165?
Even for all the numbers before.
Just click the button once and then let it go. Yeah, Jean is suggesting that, you know, we could say, I mean, and I'm saying, I'm suggesting let's just do this in terms of 13 and 15. We could think to ourselves, well, what if all of these were 13s? You know, I could have 8 times 13 and get something like, what is that, 104? And if that means, you know, I have 225 total, or I need 225 total, and so if I think to myself, well, then that means the final 121 divided by that 8, I could kind of do that. The lowest number on the right is 172. Miriam, I'm not sure what you mean by that. The lowest number, like this one has to be 172? I don't think we're really boxed into anything with such a specific number. Oh, but could be. Well, but we're not trying to see whether or not there could be one more than 165. Oh, the lowest possibility. Okay. Yeah, so conceptually, if we're just thinking of the tug of war, if we know that the average comes out to be 15, and we know we have a bunch of like 13s here. Like we don't actually know it's 13. It could be even less. It could be pulling it even farther than 13. But the only thing that's going to balance that out and get us above there would be something like, 17s and up. Does that make sense, people? That's why I think Miriam was saying that 172 is around the lowest. I'm not so sure that's true, but you might be right. I just haven't calculated that. So statement 1 does have to be true just based on that concept of the balancing act. Knowing that we have 8 13s in here, if we need to balance out to a 15 and we only have 7 numbers to do so, we need to counteract that. And we wouldn't be able to do that if we only had like a bunch of 16s, 160,000s. We would never be able to counteract how much weight was pulling us under the 15. Let me know if you have any questions on that, but that one is good to go based on the balancing principle. Yeah, Maria, let's use a simpler example if we can. So let's say that, I said in a certain, if I said that the median of a set of 7 numbers is 5, and the average is 9. So let's make it a little bit more manageable. So the median would be 7. But if we know the average of 5 numbers is 9, then we know we've got a total of 45. Stop me at any point, Maria, if you lose track of what I'm thinking. So what we were trying to do with this answer is say, nuh-uh, they don't have to be that big. I could make them smaller. If I'm trying to make these as small as possible to refute this, then I really want to make this side as big as possible. So, Maria, what's the biggest that these 3 members of the set could be? Awesome, yeah. So if I do that, 7, 7, 7, and then I say to myself, all right, well, so far I have 28, which means what does the total of the remaining 3 have to give me? Oh, sorry, my math initially was totally jacked up. We have 7 numbers with an average of 9, so 63 is our total. So Maria, what's left over for the last 3 spots? Sorry that it's not a friendly number. Right. Thank you for letting me do the work. The total of 35, right? So if I, what's the smallest I could possibly make any of those? Yeah, what is the smallest I could make any of these? I could still make it 7 again. Yeah, awesome. Good work, Maria. However, if I do that, if I made, as small as possible, then basically at the end, I've got, at this point I have 6, 7, so I have 42. That would mean the last one has to be 21. But I'm like, oh wait, my goal is to keep it under a certain amount. We were trying to keep it small. So the smallest I could possibly make these 3 guys would be to divide 35 by 3, which is essentially a little bit under 12. So if I want to make this side as small as possible, like, I want not an individual member, but if I want the biggest value to be as small as possible, I'm going to try and distribute this as evenly as possible. And so what I was sort of saying is we can still think of this as the tug-of-war concept coming into play. You have a 9 as the average, and so since there are a bunch of 7s here, in our best case scenario that are all pulling it to under, then with the 3 values that we put here, they need to collectively pull it how far over? Like how far over do we need to balance out here? Yeah. And so we can think of this as, if these three x's need to give me plus 8, then the smallest I can make x would be 8.3 would be 2.6 over the average. Hopefully I didn't lose you on that last step, but that's where the 11.6 comes from. Yeah, awesome. So on this problem we were saying, you know, because 15 is the average and there's a bunch of 13s, there are more 13s below than there will be things above, then this will have to actually go even beyond 2 above. And I think that's where Miriam was calculating her number. Okay, I really want to get on some other ones, so let's kind of move a little bit quickly through the rest of this one. Statement 2, does this one have to be true? Do we have to have a value in between 130 and 150? Not at all. I mean, you can picture basically the set that we just did, we could totally do again. We could make all of the lower numbers 130,000, and we could make all of the higher numbers the perfect, you know, the perfect even split of what's left over. Oops, daisy. So this one does not have to be true, which means we had already gotten rid of B and C once we realized statement 1 was good to go. Now that I know statement 2 is garbage, I could get rid of D. Do I have to have at least one home for less than 130,000? Nope. Again, just like with our simple example, I could make everything below the median equal to the median. And I keep going in the wrong direction. So no, case 3 also doesn't have to be the same. And really, 2 and 3 are pretty easy ideas when you think about it. I mean, just because you know that this is the median, you don't have to go below it. It can be equal. I mean, that's kind of an easy idea. And just because you know this is the average, there doesn't have to be something perfectly in between. You can have 130 and 170 and balance out to be that. Okay. Any questions on this one before we hop on to more fun stuff? Okay, I want to get to some of these mixture problems. Let's try this one real quick. All right, you guys pretty much owned this one. Certainly not the hardest thing to compute the real way, where we just literally go, all right, let me do 8 plus 8 plus 8 plus 16 and divide by 4. Did anyone avoid doing it that way? Did anyone avoid just sort of totaling up, you know, 8 plus 8 plus 8 plus 16 all divided by 4? Any other conceptual way that you would be able to think about how this new member is going to affect the average? Can you explain how, Dinesh? Or Abhishek's just like, no, man, I need it the real way. Okay, yeah, so, I mean, with this simple a problem, again, I don't really want to discourage you from taking what is a very easy, manageable approach. But JC has got the concept that I was thinking about, distributing the excess among the 4. This is a powerful idea in terms of, like, bigger numbers that you wouldn't want to calculate. So if I know that the average here is 8, we can show it again in the chart just to kind of give you familiarity with it. Sorry, I don't know what the average is. That's what I'm trying to figure out. But I know that the 8, that there are 3 8s basically, and there's a 16. Dinesh is saying this 16 is currently 8 above the average, but why are we dividing by 4? So the trap answer here is like 12, because you're thinking to yourself, oh, well, I've got an 8, an average of 8, and now I'm adding 16, so it should be halfway in between them. Right, so people are saying you have to distribute the amount that is greater than the average by the number of data points that are in the set. So this is, I'm going to erase temporarily because it's not as helpful here. We know that it's 8 greater, but we know that there are 4 things in the set. And so that's how you can figure out the change to the actual average. That means that you're going to get +2 to the average. Let me know if that makes sense to people. Again, I don't want to discourage you on this problem from just doing it this way, but this is an important concept that if you have a certain average and then you have something that is above or below it, the change from the average that it represents gets distributed evenly among, all the data points. So you think of this as, all right, this is plus 8, but divided by 4, it's only going to change the average by plus 2. Let me give you a real quick follow-up on that one. Take a look at this problem real quick. Alrighty. So the people that have answered were thinking that C is the answer, and they are correct. We could certainly, create equations here and say, okay, this statement translates as P plus Q plus R plus S divided by 4 equals huge number. And I can do the same thing here, that Q plus R plus S plus T divided by 4 equals huge number. But basically, since the only difference here is the P and the T, Q, R, and S remain the same, then P and T are responsible for this change in the average. The difference of P and T is what's changing this average. And so if when P is in it, the average is 250 greater than the average with T in it, how much bigger is P? Not that we need to know it for this question, but this is why I wanted to look at this. Yep, sorry, I didn't read that number carefully enough. I just saw another 8. Yeah, so it's going to be slightly harder than that. We're talking 5,250. Good call. Although now you've just made the math terrible for everyone. So Mohan is saying find the difference and multiply by 4. Correct, yeah. So again, the P is changing the average, makes the average this much greater. But that means that it's because it's being that difference is being divided by 4 data points, that P actually has to be 4 times as great. So since this is so terrible, I'm going to go back to assuming it was the number I accidentally misread, so that you guys can see it. This would tell you that P, if it actually did say that, with P, the average is 250 greater than the average when we have T instead of P. That tells you that P is really, 1,000 times bigger. We're multiplying by 4 because there are 4 data points, the P, Q, the R, and S. Can I change the number to the simple number? Well, sure. I mean, I could just say that this is 388,000. So my point being, if the only difference between this is P and T, and that change is making the average go up by 250, it really tells you that P is 1,000 bigger than T. Because since there are 4 data points, that 1,000 will only change the average by a difference by 250. The simple number I had accidentally misread statement 2 as saying this, Maria. The whole idea here is let me give you a simple example. If I say on her first 6 quizzes, Sue had an average score of 40. On her last quiz, she got a 54. What's her new average? Go ahead and work that out. sweet. So again, just to remind you guys, the whole concept here is, if the average is 40 and the new value's distance from the average is, plus 14, but we will end up having 7 data points there, meaning, she had 6 quizzes, and now with another one we'll have 7 data points. Then that means that the change to the average is going to be plus 2. So I mean, this is an ugly looking formula if we want to make it a formula, but you're basically saying a new value's distance from the average divided by the number of data points shows you the amount that it's actually going to move. Any questions on this idea? Yeah, I think Mohan and Dinesh are giving us ways to just get the correct answer here in terms of data sufficiency, which is great. Yeah, we could definitely get C just by understanding the concept. I was using this problem just as a follow-up with what we were talking about, the idea that when you have a number that changes the average, you can tell how big, I mean, this is kind of working backwards. Here we know how far apart this is from the average, and then we figure out that it's only going to move, even though it's 14 away from the average, it's only going to move the average 2 because we're considering that 14 over 7 data points. And this problem is that thinking in reverse. I know that this moves the average 250, and since I'm considering that over 4 data points, it's really 1,000 bigger. It's really 1,000 higher than this. Okay. Let's move on real quick. I want to make sure that we get to really the main theme here. I was just trying to build us up. But let's try this question real quick. Okay, so very few people have given an answer yet, and that's totally cool. I didn't expect that this would already be easy to you, but I wanted to try to make it easy for you. Are either one of these statements easy to figure out, are definitely insufficient to tell us what fraction of the students, what fraction of the seniors are male? Yeah, A is clearly insufficient. An absolute number is not going to help us with that. Now the whole concept here is the weighted average. We know that 80% of females have applied to college. Female applied. We know that 72% of males have applied. And if they tell us that 75% overall have applied, then that is basically giving us all we need to know to figure out the proportion of males to females. Well, since we're running out of time, I'm going to end up talking through this so we can look at a couple more examples and you can get a feel for how this works. The idea of using this chart with a weighted average is, all right, I know it balances out to 75. I know I got my females that are pulling this up by 5. And I know I have my males that are 72%. So in order for a 72 and an 80 to balance out to be 75, then I need these 2 columns to match up. I need them to end up contributing the same amount of weight. And so this first time I'll just kind of show you how that works. Basically, what's the least, I can add -3 as much as I want, and I can add +5 as much as I want. When would they actually, like, what's the recipe where they would equal out? And really this is a question about least common multiple. What's the least common multiple of 3 and 5? Yeah, 15. So the idea here is we can look at a weighted average by going, all right, if I had 5 parts of that 72 to 3 parts of that 80, then it would balance out at 75. And what this actually tells us, we can kind of just write the ratio on the bottom here, like you count up the number of parts that you needed, to make it balance out with the number of parts over here that you needed. And so this is telling us that our ratio of males to females is 5 to 3. Any questions with that so far? I'm sure this, to most of you who have not done this, you're like, yes, I have questions. This is totally weird. I want to hopefully do just a couple more problems so that you can get a sense of this actually being pretty easy math. This is actually a very ugly one, because a lot of times when you do this, there is a smaller multiple. You don't end up just kind of multiplying by each other. But the whole idea here is that this tells us that, 5/8 of the students are male, and 3/8 of the students are female. Yeah, Mohan's giving us the actual weighted average equation, which is totally cool. I just assume that you guys will see that enough in the book, and I kind of want to show you a different way. Using 100 to help solve the problem, it could, except the fact that there actually is a real total lurking about here. Normally that's true with percentage problems, but I don't actually think, key in this case, that 100 is necessarily going to help. The concept of getting B right away is actually just knowing that, let's say, let me clear this for a second. If there were an equal number of males and females, then what would be the overall average of people who applied? It wouldn't be 50%. We're saying, 72% of the males in this student applied to college, 80% of the females applied to college. If this school was evenly balanced between males and females, then what would be the overall average, the overall percentage of students who applied to college? It would not be 75, not if it was an equal number. It'd be the average of those two numbers, yeah. It'd be the perfect midpoint. When you average something, it is just the midpoint between those two numbers, assuming that they're equally weighted. So if it's 76%, then we know instantly, oh, cool, there's an equal number of males and females. Now, as soon as they give me an average that's on this side, I know, oh, there's more males than females, because the average is being dragged down towards the 72%. If they gave me something above the midpoint, I would know, oh, there's more females in this mix, because the average is tilting towards the females. So that's the whole idea of sort of, again, the concept of average as the balance beam. When we get this second statement, sorry, that's now a train wreck to look at. How can I get some of this out of the way? Hold on one sec. So knowing that we are instead getting 75%, we know that it's tipping towards the males. But what you really want to know conceptually is that if you have a weighted average, it tells you the ratio. Like, we can use the weighted average formula, or we can use this little weighted average chart. But no matter what, it's basically telling you, it is telling you ultimately the ratio of parts to parts. I know people were confused with how we put this together. I want to actually just do another one so you can see it. And since we don't really have time, we're going to skip. This is almost the exact same question. When you see that you've got, take a second to read it. We've got 9.8 years for males, 9.1 years for females. They want the ratio of males to females. Almost the exact same ingredients. The first statement is just a real number. Does not help. So that one's not sufficient. The second one is giving us the weighted average. So here's how we would set it up if we were trying to calculate it this way. The weighted average comes out to be 9.3. I know that the, so the females. The females are giving me 9.1. The males are giving me 9.8. And so here I would go, all right, well, so this is, plus 0.5 from the average. This is minus 0.2. And so again, we think, all right, what's the least common multiple? Yeah, it's skewed towards the female because it's closer to the female than the male. It's not perfectly in the middle. And so we need these sides to balance out, but we have to work with -2 and +5. So we think of the least common multiple, which in this case is 10, yeah. And so that's basically, like, you don't have to write all this stuff out. I'm kind of just writing it out so you get a feel for it. You might be able to get so good at this that you just skip to the eventual ratio idea. But the idea here is we need 5 parts female for 2 parts male, which means that 2/7 of the group is male, 5/7 of the group is female. Give me a smiley if this is starting to make sense to you. Okay, let me try and find so again, this answer choice is also B, just like the last one. And it's the exact same concept, but if they tell you the two, what each of these groups has as a percentage, and then they tell you the weighted average is secretly telling you the ratio. It's telling you how much it's leaning from one side to the other. Let's look at one other example. Take a sec to read this one. All right, so let's think about what we got. We're combining a certain number of 10% gravel, X tons, with a certain amount of, with Y tons of 2% gravel. And we're going to end up getting Z tons that is 5% gravel. So I would start this off before I even look at the statements by going, all right, if I'm going to end up at 5%, and this is pretty much telling me the recipe already. I've got +5 here. Yeah, we're getting the same crappy one we got before. -3 here. And so we did this a second ago. The way to get these parts to equal out would be to do something like that. That tells me that in the end, this is sorry, I missed one, a 5:3 ratio. Where did I get 5 and 3? The initial ones? What I'm always writing here is the distance from the average. So 10% is pulling it 5 bigger than the average we end up with. 2% is pulling it 3 under the average we end up with. Any questions? Yeah. So y over z equals 8/3, 5/3. It's not 5/3. That would be more than the actual mix. What this ratio tells you, remember ratios are part to part. Yeah, y to x is 5:3, which means that x, the whole is 5 plus 3. The whole is 8. So this is telling us basically that, y will be 5/8 of the mix, and x will be 3/8 of the mix. They want to know what is x. So, if they tell me that y is going to be 10 tons, then I basically know, yeah, the answer is D. They have like 10 tons is 5/8 of the mix, then I can certainly figure out what 3/8 would be. And if they tell me that the whole mix is 16 tons, then I'll go, cool, I'll just take 3/8 of that then. Looks good. Any questions on that one? I mean, I know we're rushing through the actual statements, but it's just the idea of setting up that initial chart. Maria, I can tell you're not loving this. After I stop the recording, if you guys are totally stumped, you can certainly wait around and I'll try and explain it again. Let me see if there's just one more question we can do going overboard. Hold on one sec. Okay. Let's try this last one. I'll give this give you guys a minute or so to try this. And Miriam, if you have any more description that you can tell people about, please please do so. Okay. So again, let's appreciate sort of the characteristics of the problem that lead us in here. We're still talking about a group where you're either one thing or the other, you know, male or female, manager or director. And they're asking us either for the fraction of one versus the other, the ratio of one to the other, or the percentage of one versus the other. All identical ideas. So here we know the average salary of the managers is $5,000 less. I mean, how could that possibly tell me the percentage? And same deal here, the average of the directors is 15,000 greater than the total average. That couldn't by itself tell me anything. But together, does it do anything? Is there any way that together these give me a sense of the ratio of managers to directors, or how the tug of war is going down? Nice. One way to sort of visualize it real quick, the difference is 20K, yeah. So if we put this on a number line, we would be saying the average is here, right? The managers are 5 under. The directors are 15 over. How do those numbers relate to each other? Cool, December 17th apparently. Do you mean a year ago, I hope? Because what's today? Okay. Not the future, not 2 days in the future. Okay, 2009. So what's the ratio here of these differences of 5 under and 15 over? Yeah, one is 3 times bigger than the other. So this is kind of that, yeah, a 1 to 3 ratio. What does that actually mean in terms of the number of managers versus the number of directors? Does that mean that there are 3 times as many directors? Does anyone know what it does mean? Yeah, it's the other way around. The way average works with this tug of war is that, you know, if the average is much closer here, if it's, you know, being pulled 3 times as far this way as it's being pulled that way, then that means that the manager to director ratio is actually 3 to 1. Because when you think about it, like, there's 3 times as much distance being pulled towards the manager side as there is here. Another way we could visualize this, you know, using the same old chart, we don't know the actual average, but knowing that the managers are 5 below, and knowing that the directors are 15 above, Maria, what's the least common multiple there of the -5 and the +15? So how many manager parts do I need to add to get up to 15? Yeah, I mean, I technically only need to add 2. I need to have 3 of them. So a lot of times, actually, when you use this technique, it looks like this problem. The ones I showed you were kind of ugly versions. The ones you find in the official guide are actually normally pretty, where one of the numbers already is a multiple of the other one, and so you get this friendly sort of build-up. So again, the way we read this off at the end would go, oh, okay, so I needed 3 parts of that manager value to balance out to 1 part of that director value. So that means that these guys are in a 3 to 1 ratio. If I know that they're a 3 to 1 ratio, I know that the manager is 3/4 of the whole, and the director is 1/4 of the whole. Because remember, we add up a ratio to know how many total parts it's out of. Awesome. And since this was a question about percentages, Key is saying, so let's just convert that bad boy to 25% and 75%. All right. Any questions on this one? So the answer is C, because together, here they're not, I mean, here we don't know the average, but by knowing the distortion that, you know, this is 3 times greater than the midpoint than the weighted average than this, gives us a sense of that ratio. Alrighty. Well, I'm going to stop the recording there since I know that we've already gone over. But But if any of you guys want to just stick around for another quick explanation, like a simpler example of this, feel free. Otherwise, it's been nice hanging out with you guys, and I will talk to you later.